Good afternoon, everyone. Uh, I want to continue the topic we started last week, so on waves. I told you last class that you already know the definition of waves, even though from your last term work, and you know the types of waves. We have mechanical waves and we have electromagnetic waves. Mechanical waves are the types of waves that require material medium for their propagation. Electromagnetic waves and in ways that do not require material medium for their propagation. You can see in this aspect, we want to go look at the mechanical waves in full. Now, these mechanical waves, they are the ones that require material medium for their propagation, and electromagnetic do not require material medium for their propagation. We are talking about types of electromagnetic waves. We'll be talking about light waves, we'll be talking about sound waves. So later we will treat that. It's also part of this 10 work. So especially light waves and sound waves. So they are very broad topics that we look into intensively. Now go back to mechanical waves. Now mechanical waves require material medium for their propagation. Types of mechanical waves: we have transverse wave. Transverse wave is the type of wave that travel parallel to the material medium. They travel parallel to the material medium. In these types of wave, the waves, if you have a wave in this way going this way like this, if this is the material medium like this, and the wave will be going up and down like this. Example of that is we have it in a ripple tank, we have string, we have x-ray. So the wave they travel in opposite direction to the material medium. So that is why you can see this is up and down, this arrow here. Then we have longitudinal wave. Longitudinal wave travel perpendicular to the material medium. So it means it travel along with the material medium. So that one goes in a straight line. You can see this arrow that I show here. You can see them it travel in a straight line. So the example of this one, when you are doing if you are skipping now, somebody rope here and another person at the other end here. So you see if they are what do you call it? If you are displaying that rope, you will discover that the wave will be traveling from the other person here to the other end here, and it will be going to and fro in that manner in a straight line. So we have standing or stationary wave. I'm talking about the standing and stationary wave. Is a type of wave whereby longitude, whereby the amplitude, frequency, and wavelength they travel in opposite direction. It's in that note that I sent to you. This is of the example of standing or stationary wave. You can see we have two types of wave. One is traveling this way, you can see the movement, and other one is traveling in opposite direction. It now look as if they cover each other, so they travel in opposite direction. We are talking about the progressive wave. Progressive waves is type of waves where the amplitude, wavelength, and the frequency they travel in the same direction. Example of that one, you can see the way this wave is traveling. We have two waves here, they are moving in the same direction. Can you see it now? So that is progressive waves. So if you are talking, and we have terms using in wave. So we have amplitude, we have wavefront, we have phase, vibration, wavelength, period, and frequency. So we're talking those ones that are very, very important now. We're talking about the wavelength. So we are talking about amplitude. Amplitude is the maximum displacement from this place to this place here. This height, the height of the wave is what we regard as what? As amplitude. This is amplitude. Now we have another thing we call crest and trough. The one this the half of wavelength is called crest. The one that is in positive direction of y, this one up here is crest, and this one down here, the one in the opposite negative direction of y axis, is what we regard as trough. You can see it in this label here. You can see it in this label. This is crest and this is trough. Now the addition of this trough and the crest and trough is what we regard as the addition of the two is what we regard as wavelength. This one and this one is called wavelength. That means in this diagram now, how many wavelength do we have? Look at this, look at this. This one plus this one is one wavelength. this way, and from here to here is another wavelength. From here to here is another wavelength. This one is half wavelength now. That means from this place to this place, this is 1. From this place to this place, this is 2. Here to here is half. That means all what we have here is 2.5 to this point. To this point is 2.5. Now, look at it. We are not talking about period. Look at the definition here. This is the time taken by a particle of a wave to perform one complete cycle of or oscillation. Now, another thing is this: we want to calculate the period. We have it time. Period is equal to time taken over number of cycle, or time taken over number of wavelengths. In some cases, take note of this formula. Now, if we are talking about the frequency, frequency is the number of cycle or oscillation which a wave completes in 1 second. Number of cycles or oscillation which the wave completes in 1 second. So, and it is measured in hertz. That is what? That is the unit. Now, frequency is equals to what? Frequency is equals to 1 over period. Frequency is equals to 1 over period. From the note I sent to you, there's another way by which you can get your frequency. So that is if you are talking about the angular velocity. Look at this formula here. Look at this formula. We have our angular velocity, so it equals to